Yeah, that's cool.
If Wi-Fi gets goofy, just have her call me. I have like one that's like my own. I can bring it here.
Okay, sounds good. Yeah, thank you.
I have one. They don't need it. Well, they use Wi-Fi, but if it gets goofy, just yeah. If it gets goofy, just tell Bill and he has one.
Okay.
I'll do it in tech reporting.
So you good to go? Like,
Yeah.
just fine. I'll just like hang out here. Like, you tell me what to do. So I'm just watching the chat and everything. Just get an update.
Okay.
That's pretty much it.
So you can follow chat and let me know. Sounds good.
That's what I did. I changed that part of it. Right? Like just,
What was that, sorry?
I just changed the thing saying nobody was what's a jabber I'm gonna do. So
Okay. Okay. Sounds good. And then after this, they can request control of the slides and do it themselves.
I can do it. Just like I can.
You can give it control. Okay. Awesome. All right. 9:30.
I just did it for the back end term, so like the UI changed a little bit.
Okay. Sounds good. Thanks, Rich. All right, everybody. Can everyone hear me? Okay. All right. Yeah. Thanks, everyone. IETF 119. This is the BPF working group. Thanks, everybody, for joining us. This is our third official BPF working group meeting. Fourth? Third? Okay. I'm David Vernay. This is Suresh Krishnan. Let's just go over the agenda as per usual, a few other notes as well. So as always, we're going to start with the note well. If you're not familiar, please read up on the note well so you can remind yourself of IETF policies on topics like patents and code of conduct. This is an IETF meeting, so we're going to live by the IETF code of conduct. Everybody should be respectful and courteous of each other at all times. This is IETF. We know what we're here for. As we'll talk about later as well, there's always going to be a mix of IETF people, Linux kernel people. This is a community of both. So anybody from any background is welcome, of course, to participate and help drive this forward. Here are the administrative tasks. You have an Etherpad here, Meet Echo. Does anybody have availability or desire to take notes for this meeting? Thank you. Appreciate it. Yep. All right, here's the agenda. We're doing the bashing right now. Shouldn't take much longer. Then Dave Thaler is going to jump in to go over the latest for the BPF ISA. Yeah, Dave's here. To go over an update on everything that's changed in the ISA specification document since IETF 118. Following that, we'll have another 15-minute presentation given by Dave on the callx instruction, the indirect call instruction in BPF. And then following that, Nalini Elkins, I apologize in advance if I mispronounced your name, but she's going to be giving us an overview of some implementations of BPF and how that's being leveraged.
Can I pause for a second?
Sure,
Like
yeah.
The meeting is not showing the slides, so let me.
Oh,
put them. Okay.
yeah. People are chatting that?
Yeah, like
Okay.
they were saying.
Oh yeah, there you go. How did you do that? On the bottom? Okay. Here, let me.
No,
You got it, yeah.
Yeah.
Okay. So yeah, sorry about that, everybody. Code of conduct, the administrative tasks, somebody already kindly offered to do the note taking. Yeah, here's the agenda. The bashing we're doing now is a specification. Like I mentioned, Dave will be taking over after this for about a 45-minute discussion, which could go over depending on what we discuss. The ISA document is now in last call, so we want to try to get as many things taken care of in this discussion today as we can. Obviously, if you don't get everything, that's okay. But it's in last call, so now's a good time to raise any thoughts you have. After that, we'll be talking about the callx, the indirect call instruction, again led by Dave, probably about 15 minutes, and then Nalini will be discussing an implementation or an application of BPF, I should say, being used by them. Yeah, so that'll be interesting as well. About 20 minutes. All right, that's about it. Oh yeah, sorry. So as I said before, newcomers are welcome. BPF, it's not our first meeting, but it's a large ecosystem. Everybody's willing and more than welcome to participate. And if you have questions, the floor is yours. So that's all we had. Any questions before we get started and hand off to Dave for the ISA discussion? All right, great, thank you. And Dave, take it away. I think, yeah, you should be coming up soon.
All right, I clicked ask slides.
I did give you control. I gave you control, Dave. Do you have it?
Not the same way as when we tested it right beforehand, because it's on the chair's slides right now. Change deck. Let me try this.
Yeah, it's
There we
coming up
go.
slowly. Yeah, it's coming up.
All right, here we go.
Yeah, cool. Thanks.
All right, how's it presented?
Yeah, it's looking good, Dave. Thanks.
Okay, great. All right, so I am Dave Thaler, independent, for the first time at IETF here. So let's go ahead and get started. We'll talk about the things from last time. My goal is to spend only very little time on things that are trivial. And so the first couple of slides I'll go through pretty quick unless people have questions, and spend most of the time on things that are more technical. So just some history in case anybody is new in the meeting here. Draft 00, which was not the first version of the document per se, it was the first internet draft format, was in October, which we discussed at IETF 118. We've had a bunch of discussion on the list, a bunch of patches merged. Draft 01 was posted on March 3rd, and then the working group last call started March 7th and lasts until at least April 5th. I think in the working group last call announcement, it said at least 2 weeks after the conclusion of the meeting. It didn't actually set a deadline. And so April 5th or later, the chairs get to decide what the closing date is. So.
The intention for now is for it to be April 5th. Yeah, thanks for clarifying.
Okay. Okay, excellent. So you still have time to review. So if something jogs your memory at this time, to follow up and comment on later, that's perfectly fine. All right, so let's talk about, I've been using the GitHub repository. The GitHub repository was presented even back in the BOF for tracking of open issues, right? The actual changes to the draft, right, go through the process that goes to the Linux kernel repository, but for tracking what's the status of issues and what's been responded to and so on, I've been using the GitHub issues to track, basically it's my own to-do list. It's public, and so anybody is welcome to see it and see the status of stuff. So I'm just highlighting that that's where things are. The repository as created does not have ISA in the name, so it's the IETF working group / BPF. eBPF docs, and so anything that's for the ISA document has a label that's tagged as ISA. So just because it's in there doesn't mean it has anything to do with the ISA document. So sometimes it's unclear, and then it gets tagged or removed based on discussion about, oh, this doesn't belong in there, right? Or it does belong in there. Okay. And so in terms of velocity, we've addressed 19 ISA specific issues since IETF 118. That's a good run. And there's been a couple that opened since working group last call started, mostly just typo trivial things that aren't necessarily worth discussing, but I'll still show them at the end. So, so this is my one slide on editorial notes. I'm not going to go through these, but these are things that's that list of stuff that I don't think needs any discussion. They were pretty trivial. If you want to talk about something, feel free. We can come back to it. But these are the ones that to my knowledge, there's nothing to talk about. So just giving visibility that there's a whole bunch of things that are just editorial nits that were addressed or clarifications, typically cases where 2 places in the document were inconsistent with each other, and we updated them to be consistent, right? That's the general trend. One editorial change just worth noting is that we actually changed the document title. The document title is now consistent with the charter, right? Where the charter says that we do the BPF instruction set architecture. So we renamed the document to actually say that, because we always refer to it as the ISA, but it didn't use ISA in the title. So that's an example of one that just to highlight. All right, so now we're getting into the technical things that have been done since last time. So this is, I don't believe there's any open issues here. We're just reporting back out that this has changed to confirm consensus was that I did it correctly. I think that we've already gotten merging on the kernel list, right? But we're being able to report it back to everybody here at IETF. So first of all, the first one had to do with how legacy packet instructions are handled in the document. So there was 2 very closely related issues. One was about what set of opcodes are deprecated. Okay. Back in 00, you could read the text and you could read it as saying, all possible combinations of APS and IND opcodes are deprecated, including ones that were never used. And so 01 updates that, as we'll get to in a second here. The other one isn't about the opcodes, it's about the other fields, right? So for the opcodes that are used, what's the values of dest reg, offset, and source reg, right? Where you could read 00 as saying all possible combinations are deprecated, whereas in reality, the only things that were ever used are cases where those are 0 for dest reg and offset, and 0 for source reg in the ABS case. And so 01 makes the text be more specific and the appendix likewise be more specific, so that we only deprecate the things that are actually used in the wild, and that leaves the unused space available for future assignment. Okay. I'm going to keep going unless there's any questions, right? Because this is all stuff that we've already done and kind of already hashed out on the list, right? So then there was a set of things that were not specific to the deprecated instructions. Some of these are about some new instructions. Some of them are about old instructions, just making the things be more explicit, even though some of these were kind of implied, but it's better to be explicit. The first one was about a new instruction, the move with sign extension instruction. We clarified that this instruction is only defined when the source, it says that you're sign extending a register, right? There's no real use case for sign extending an immediate value, right? You would just use a different instruction, right? And so this clarifies that there is no such thing as a move X without the source equals X bit. That's an undefined space, right? Similarly, some of the jump instructions were kind of implied because it said unused fields are set to 0, but we made those be pretty explicit. So the exit instruction, for example, needs source equals K. Well, the source isn't really, is kind of a don't care, right? Because there's no value that you're using with exit, right? And so whether it's a register, an immediate, it's kind of a, is it K or X? It's arbitrary, right? And so it's just defined to be 0. And so things like that, it kind of already said that before if you squinted, but now it's just explicit. So that was just an editorial change. Same thing with regular call, meaning with source equals K, and the same thing with jump always. All of these is just being explicit about things that were kind of implied before. And then finally, similarly with the negation operation, meaning like arithmetic minus, again, source equals K. So that's just clarifications that help to improve the document and to help to avoid bugs if somebody's going to implement off of the spec. All right, now we're getting to the ones that were actually touching more of the document. So this one touched a large percentage of the document, but it was purely editorial and doesn't affect code at all. This one, I don't know how to pronounce his name, Ao Yang Fang, it's my best guess anyway, pointed out that there were various cases with 4-bit fields where the spec talked about 8-bit values for them. So for example, BPF underscore sub equals hex 10 is an 8-bit value. The field is the left 4 bits of those, right? So 1 in the field you're talking about here and 0 in the other field, right? And so it was, sometimes it did this and other times it just said, here's the value of the 4-bit field. Okay. So we said, what do we do about this? And so we had some list discussion. And the consensus on the list that the chairs called was to try to use the usual IETF conventions, documentation conventions, that define 4-bit values for 4-bit fields and 2-bit values for 2-bit fields and so on. And so we reformatted the document to be consistent with the way things tend to look in IETF RFCs. Okay. In order to prevent conflicts in terminology, then I dropped the BPF underscore prefix from the fields defined like this. You can see, whereas it's BPF sub being the full opcode 8 bits is hex 10, the sub bits just being 4 of those doesn't use BPF underscore. It says sub equals 1, which is a 4-bit value, right? So now there's not a case where you put in code, you say BPF sub and get a conflict or whatever. Those are 2 different things depending on what you're implementing off of the full 8 bits or implementing off of the 4 bits. So documentation convention. And so the diagrams changed to use the classic IETF look, which is illustrated on the bottom there, rather than the C-like struct definitions with, :4 for a 4-bit field and things like that that the document used to use. Okay. So again, there's nothing that it says now that it didn't say before. It's just the style of documenting it now matches what's typical in RFCs. And this resolves the issue that Aoyan raised. Okay, but that one, the majority of the changes in the document, number of not lines of change in the document, that one accounts for probably more lines of change than anything else, just because it touched lots of different places in the document to make the same change. All right, not seeing questions. I'm going to keep moving. The next category had to do with the discussion around documentation of 64-bit immediate instructions, right? There's a section that's basically called that. Okay. In draft 00, there was text that introduced the formatting of instructions that said, or at least implied, that all 64-bit immediate instructions use this thing that it defined as IMM64, which it put two fields together to calculate that. But it turned out that only one of them does, and so that was a little bit confusing. So in particular, out of all the immediate instructions, one uses that. Two of them use IMM and the next IMM field for different purposes, right? They're not combined. They mean two different things in the use. And four of them don't use next IMM at all, and so you always set it to 0, okay? So we said, since the computation of this IMM64 is only used by a single instruction, not all of the 64-bit immediates, then we moved that computation. I think it was, I don't know if it was Christoph or Younghong that did the change, but thank you. Anyway, the change was moved down into the one instruction. And so now there's no such thing as a IMM64 that appears in the document anymore. It's just the one instruction contains the computation for how you compute a 64-bit value. Everything is done in terms of IMM and next IMM. And there's a little diagram down below that shows, when it's a 64-bit, then the following instruction, instead of being shown as, opcode 2 and regs 2 and offset 2 and so on, it's just, reserved, right? Must be 0. Because they're not really an offset field. I mean, you could because it's reserved, but it's just IMM and next IMM are the only things that are used. So that's the diagram as it appears now. And it still explains in the text that contains a pseudo instruction with opcode, desreg, source reg, and offset all set to 0. That text still remains. So if you want to describe it that way, that's fine. The document still does. So. Okay. Most of the discussion that we had at IETF 118 and on the list was actually in this category of how do we deal with conformance groups, right? This was the main topic last time that we said we could go to a working group last call after we resolve how we're going to do this. And so this is where most of the actual work was in this category. Okay? And this is split between two different issues, but I'm just going to combine them together to cover conformance groups because this is the main set of work that was done since IETF 118. I'm also going to give a little bit of an implementation report because we had implementation work that resulted in some of the issues that then got clarified. And so that helps to give faith in the correctness and completeness and clarity of the text, which is good. So, all right. So what we talked about at 118, just to recap, we said that we were going to use, quote, logical units of functionality. That was the term on the slides that we used. As opposed to something else, whether it was, playing CPU version numbers or whatever else, okay, as the things that would define groups of what you claim conformance to. The result of this choice is that the current Linux kernel is, of course, RFC compliant, sort of by definition of the spec, right? It's documenting what's actually in use. But this choice was that older versions, that at least there's no current reason to make, come to you in just a minute, Christoph, that older versions of Linux and Windows or anything else are not necessarily RFC compliant, right? Because they may have some combination that we're not specifically crafting conformance groups to meet that, right? And so even the basic one, they're going to say, you can't say it's RFC compliant. Only the latest one is RFC compliant, right? We want things to be RFC compliant going forwards. There's no current request to retroactively try to make older things be RFC compliant. And if you got a question on that, I can pause here, Christoph. Otherwise, you can wait till the end. So,
Yeah, Christoph, go ahead.
Well, and the other important point is only like the prime maintained Linux architectures are RFC compliant. All the various like not perfectly up to date architecture ports aren't either, but that's kind of expected.
Yep. True. Thank you, Rissa. Okay. So again, this is from IETF 118. That
Sorry.
oh, go ahead.
Yeah, the other thing to probably mention is that the conformance groups basically match what RISC-V does. So the idea is that if you're a vendor implementing parts of the ISA for BPF, then you're probably, I mean, you might be using RISC-V, and you know we're sort of following the contours of what they're laying down for what they consider to be logically conformant groups of instructions. So yeah, the older versions aren't RFC compliant, but I would say kind of looking forward, it's sort of, we're kind of looking towards what we think vendors would care about. And yeah, hopefully RISC-V will represent that.
Yep. So in its current state, meaning how you write things at the beginning, right, as we mentioned at IETF 118, every instruction that exists right now in the ISA is in exactly one conformance group. That's because we don't have a reason at time 0 to have any instruction be in more than one. But over time, an instruction can be in multiple groups because of the way that addition and deprecation mechanisms work. And I have examples on later slides, right? But the intent is, by default, every instruction is in exactly one. But you'll see that that is not a documentation constraint. It's just that's what best practice is, right? And what makes sense technically. And whereas before we had conformance groups, every instruction we would have to individually track whether it was permanent or deprecated, what the registration status is. Is it deprecated? Is it not deprecated? Is it, vendor specific or whatever it is, right? We'd have to track that on a per instruction basis, right? By switching to conformance groups, we said the granularity of tracking that is not at the individual instruction basis. It's at the conformance group basis, right? So you can deprecate an entire group, or you can take a group of stuff and then decide to standardize it, that type of stuff. And so you can still make groups as small as a single instruction, so there's no loss of generality, but it is certainly simpler to deal administratively with a status per group rather than a status for every individual instruction. All right, so here's the set of conformance groups that were discussed on the list, and what the document has matches. And I think, as David mentioned, this list was in part constructed based on looking what RISC-V does. Oh, I see a typo there. The two div mul ones, the 64-bit division is missing the comma multiplication, and those two should match, right? So I think you guys get that. So for most of these, there's a 32-bit variant and a 64-bit variant. For the legacy packet instructions, that's the only one you can see in the bottom right corner. That's the deprecated set. Everything else is not deprecated. See the status there? So the includes column means that if you claim conformance to, say, base 64, then it means you can't do that unless you also automatically conform to all of base 32. So base 64 includes everything in base 32 plus everything explicitly tagged as base 64. And the same things for the others. And so let's say if you were saying, what does the latest Linux kernel support? You'd say atomic 64, base 64, divmul 64, and packet. Okay, that would be the answer for latest Linux, right? For some other runtime, let's say you had an offload card, then you might not have the 64s. You might say base 32 is the smallest one you could possibly support and be RFC compliant, and just say base 32 only, right? And various other variations are possible for other runtimes or offload cards or what have you. Make sense? Okay. So I'm going to give a brief, I'm going to interrupt the regular thing while I'm on topics of conformance groups to give some implementation status on this one. Just to say, how well did we do at describing it? Is the tables complete? Are we confident that we don't have errors in it? Because there were issues filed during this one. There were 2 typo issues filed, I think, after working group last call started, and they're kind of all in this category of just implementation status, making sure there's no typos in it and so on. So the first one, there's an open source project that the link is there on GitHub. This is the BPF conformance suite, and so this is an open source project that has a bunch of ISA conformance tests. Okay, I'm sure there'll be more and more added over time, but there's a lot of them that are in there now. as of about a month ago, that project now supports conformance groups. So what does that mean? Okay. Well, it means that the user that's going to run the conformance test can specify what groups to include or exclude during a conformance test run. Okay, so if you're going to test, a particular runtime that doesn't support the 64-bit ones, you can say do a run and just use the 32-bit ones and see if it supplies, pass. Okay, or I wanted to supply this new one. Am I there yet? And I can run it, and it'll say nope. Atomic 64 fail, that kind of thing. Okay. By default, if you don't specify, then it uses the set of groups supported by the latest Linux kernel, which are the ones that I mentioned before, right? Base 64, Atomic 64, Diml 64, and Packet. Right, that's the default if you don't specify. This open source project is then used for testing at least 5 other open source projects, although BPF Conformance itself has a test suite that tests, meaning a CI/CD run that tests it against the Linux kernel as kind of a baseline, right? So it's Linux kernel by being used by BPF Conformance, and then 4 other projects use BPF Conformance. I see a hand up.
Yeah. So Dave, I kind of did not get this historical thing. So I had a different understanding of historical. So so you're saying the deprecated also goes into historical, right? So maybe we kind of need to rethink the registration policy for that, because we probably don't want to write a whole spec for changing something to historical, right, from permanent, in case we want to deprecate it, or either come up with a new status, or change the policy on how we change things, from just the status, because I thought deprecated was something different than historical. So maybe we probably need to rethink that. I just realized that. So
okay, I'm going to repeat back what I think you're pointing out, because I think you're pointing out is not actually on the slides, which is go back one. So when it's historical right now, for every status, there's a IANA policy associated, right? Whether it's IETF standard or expert review or whatever. And today the document says historical requires specification required.
Correct.
And you're saying you would like to see that drop to expert review.
Something so I kind of wonder, I always thought of differentiating registering something as a historical thing that happened before, or changing something to deprecate it. The deprecation could change the status of historical, but it requires much less lightweight process. That is kind of what I was thinking. We can noodle on the text afterwards.
No, that's great to appear in the minutes. I would support that proposal. You're right, that's not what the document says right now, but historical and deprecated right now are kind of synonymous. But you're right, it says specification required right now. And if you're saying that's probably too onerous, that sounds fine to me. Dropping it to expert review sounds great to me. If we file an issue for that, I'm happy to author the patch that does that. So
okay, thanks, Dave.
So what's the logic for making it more onerous to like less onerous to drop something to historical? Why would we want to make it less onerous to do that?
Let's say we want to deprecate something, right? We don't want to write an RFC to do it.
Specification required does not require an RFC. It just requires a document that's referenceable. It could be a text file in the Linux kernel tree.
Okay.
That's a specification, right? It's whatever the designated expert decides is sufficient documentation.
Okay, so let's talk about it, Dave. Okay, so
okay. Take it to the list then.
Yeah, because I think we probably need more discussion, because Dave doesn't want to make it easier, but we can talk about that too.
Yeah, I mean, I guess I think the default assumption so far has been that it should be a relatively high bar to both add and deprecate instructions. And I'm not opposed to changing that, but I think I would be curious to hear what we think to gain out of making it easier. Yeah.
I personally don't care either way, so but I'm okay with authoring a change if the working group wants that, but I don't have any preference either way. So, all right. So I'm going to continue on. The other project that it's been implemented, and I've got a slide just on the implementation status of each of these, is what the result was. The other one is Prevail is the name of an open source verifier that can be used by multiple runtimes. It's used by eBPF for Windows, and I believe it's used by at least 1 or 2 other runtimes that I don't know the names of. Go ahead, David.
Yeah, sorry. I was curious for the BPF conformance. So
Mhm.
what is it? It tries to execute the instruction, and then it sees if like the JIT accepts it or rejects it, or like could you maybe go into a bit more detail just out of
Oh, sure.
curiosity?
Yeah, sure. What it does is the BPF conformance suite, which I am not the maintainer of. Ellen Jowett is, but I have contributed stuff to it. So I guess I'm a contributor, but not a maintainer. And so I'm familiar with how it works because I've contributed code to it. The way that it works is it is a framework that can then run a plugin. And so if you're going to integrate it with another runtime, then you'd write a plugin for that runtime that BPF conformance would invoke. And so it can pass in a set of instructions and what the input memory is or whatever it is. And then what the plugin reports back is what is the result, what is the value, I think it's of R0 at the time of the completion of this set of instructions. Okay, so there's a way to pass back. And then what it does is it compares that against an expected answer. Okay, so the conformance test suite, a conformance test, is a set of one or more instructions to be executed by the plugin and an expected result that comes back.
Gotcha. Okay. Yeah, I can take another closer look at the code. My initial expectation would be if a JIT didn't accept an instruction, that it wouldn't really, there wouldn't be like a semantic meaning of what was in R0 at the end because it wouldn't have executed it in the first place. But
correct. So there's a couple different results of a run for a particular test case, right? It can come up with the correct answer, it can come up with the wrong answer, or it can hit an error before it can come up with anything. And that would be your example of where the JIT fails, and so you can't actually run it, right?
Okay, gotcha. Cool. Thanks.
And so that's what it does. And so since the core part is agnostic as to what it's running against, that's the job of the plugin. In this case, there happens to be 5 different plugins that exist for it, whether in the BPF conformance repository or in some other using projects repository. Like eBPF, for example, is another project that uses it. And I believe it's in the other direction where eBPF consumes BPF conformance and then runs it against the eBPF interpreter and against the eBPF JIT compiler and execution environment. Okay. And I think like the Rust BPF is another one that uses it, and BPF for Windows is another one that uses it, and I think there's one other one. But anyway.
Nice. Cool.
Okay. So the verifier is against a project that is the preval verifier, I should say, is a runtime agnostic project that's used by BPF for Windows and other runtimes. Okay. And this one, the verifier, was updated to use conformance groups. You could use the verifier with different runtimes that themselves use different conformance groups at the the JIT level or whatever else. So, so both of them were done off of the spec and nothing but the spec. Okay, to say okay, if both of them do good results and pass with the correct set of instructions, the test cases themselves, then probably the spec was well written. At least that's what it's checking anyway. So here's the status of that report. So BPF conformance currently has tests for everything in base 32 and base 64, except for 2 things are missing. And so in other words, there may be things that have not yet been detected as far as wording or whatever else. It's still missing tests for calling a helper function by BTF ID, and it's missing tests for the other 64-bit immediates with source greater than 0. So those are the only gaps per se. All the other ones are fully supported, and the legacy packet instructions are not supported, but they're deprecated, so who cares? The status in the prevail implementation, and it does the same kind of thing. Is right, if a runtime uses it, the runtime exposes to the prevail verifier the set of conformance groups that it supports. And so when the verifier runs, it runs as if those are the only ones that are supposed to be supported, and everything else should be failed, and so on. Okay. So this one is also missing at current implementation status, just like the previous one. There's a couple of gaps still. At least the first one is already in progress. The BPF to BPF calls, that one's already in progress. The other 2 are the same as on the previous slide. And so both of those still need to be done, but they're actually simpler to implement too. So maybe they'll get done sometime soon, but I'm sure both of these are open source projects anybody can contribute to. So those are still gaps that need to be done. But again, everything else below that is already supported. And of course, Packet is partially supported, but it's deprecated. So who cares? Probably that one will never be completed because over time, the runtime should say, I just don't support that. So So that means for everything that says support it, and with the exceptions of what's called out in the issues, I'd say I'm pretty confident that the document does a good job and doesn't have typos or errors or anything in terms of how those are described and how the instructions are described, because there's multiple different implementations off of the spec for everything other than like the calling a helper function by BTF ID and the 64-bit immediates with source reg greater than 1 or greater than 0, depending which project we're looking at. So that tells me that I don't have concerns about getting to the end of working with last call, but it also tells me that if those are done before April 7th or April 5th or whatever it is, then there's some possibility you might see another issue raised. So. All right, going back to the document instead of the implementation reports. So we defined processes, which the charter said we needed to, for adding instructions and deprecating instructions. And so first I have the actual text on the screen, which don't expect everybody to read through. I'll highlight things, but then I got an example, which might be easier to follow after the text. Okay. So the notable things that you'll see is conformance groups, once they're registered and published, are considered to be immutable, because once they're published, then you can have somebody that's implemented off of them claiming conformance, and then you can add new conformance groups, but you don't change existing ones. So that works like an RFC does, right? It's immutable. And so conformance groups can be published in RFCs, and it's not surprising the immutability is the same between an RFC and a conformance group documented in an RFC. You can create new ones and deprecate old ones. That's perfectly fine. And so we talk about how you can add new instructions over time via the groups column. And so let's look at an example to be precise. And the example, the text here is in the document, the example is not. Maybe that's a question. Would people like to see the example put in the document? Because it is there for the deprecation case, but not for the addition case. Deprecation is more complicated, so maybe you don't need an example for the adding, but I'll feedback welcome. So let's say you start with this before adding stuff. And so this is just making everything be hypothetically agnostic here, right? So you have a conformance group at the beginning that says it's called example, right? That's saying with the conformance group doesn't exist, it's an example. And it has 2 instructions in it with 2 opcodes, call them A and B. And so now you decide you want to add 2 more instructions. And gosh, it sure would have been nice if instructions 3 and 4 were in the original example one, because now we've added 2 things that are similar. What do we do? So here's what it would look like, okay? Because what you're seeing on the screen is what it looks like in the IANA registries itself, right? The expectation is that there would be one IANA page with 2 sub-registries. One sub-registry on the top of the web page is the set of conformance groups, and one is the set of instructions, which is the long list of all the instructions. Okay? So this is kind of excerpts. And so what do you do if you want to add some instructions? Well, after you add it, so you write a document that says that the end state will look like this, okay? And so in this case, maybe I'll start with the bottom here. We've added 2 new instructions, right? C and D, right? They're example instructions 3 and 4, and we can't put them in the example conformance group because example is immutable. But we can create an example v2, right? There's nothing special about versioning. I just used a string that was different, right? So in this case, example v2 is a maybe for you guys to understand, but it doesn't have to have the letters v or 2 or anything. That's just arbitrary, right? And then in the conformance group section, you say example 2 is a new label that's been created. We have some description that goes associated with it. And it's also permanent, but we say that it includes example. So that means that example v2 includes everything with the example label, or everything that example would include, plus anything explicitly tagged as example v2, right? So now if you say you're conformant to example v2, it means you have to support all 4 of the instructions in the bottom, right? 2 of those because they're an example that example v2 requires, and 2 of them because they're explicitly an example v2. So the use of the includes column is the same as back there when I showed that, say, base 64 includes base 32. It's the same kind of definition of includes, right? You can't claim conformance to the new one unless you have everything in the latter one plus. Okay. Now this plus, I haven't talked about the excludes column yet, but this is how includes work, which is all you need for this example. Okay. So over time, you might be adding 1 new conformance group and just labeling new instructions with this and taking care of everything else with that includes column to say this is the new version of. Okay. So adding stuff over time is pretty easy, just means that we have a new label for the new set. I see a question from Eric Klein in chat. And he asks, relevant questions, I'm going to take the question live here. Eric asks, A and B don't get a comma example 2 in their groups column? Answer, no, because that's administratively more difficult than just using in the top one, it says include. So it's implied, and so the groups column does not have to be dynamically updated just because you do this, right? Because when you look at these two tables together, you get the same answer as if you had annotated A and B with example comma 2. But what this is it means that you only have to touch 3 rows in the entire page instead of, consider the case for example had 100 instructions in it. Like you're going to add something into base 32, right? That would be pretty onerous to the registry, right? As opposed to I want to add 1 instruction to base 32. Do I have to touch all the base 32s? No. Okay. So thank you. I see a +1 there. Okay.
Thanks, Dave. Jagan, did you have a question on this topic?
Yeah, actually, I have a question. Like, if you say like I'm going to example version 3, right? So then the includes will contain example 2 or both example and example 2, version 2.
Yeah, good question. And the answer is the same because example v2 already includes everything in example 1. And so it would be the example v3 would have in the includes, it would say example v2. Okay. And so to answer your question, includes is recursive.
Okay.
Transitive closure, right? So if something includes example v2, because you can't claim conformance to example v2 unless you claim conformance to everything that it requires, right? And so v3 says you got to be compliant to example v2 plus anything explicitly tagged as v3.
Okay, yeah,
So
thank you
again,
very much.
this is designed to minimize the total number of rows you have to update, which is least administrative work and least opportunity for Anna or somebody else to make a typo, right? So
That's right. Yeah, thank you.
Okay.
Go ahead, Dave. Thanks.
Okay. All right, but good questions. Good questions. All right, so now let's go through the deprecation example, which is marginally more complicated, but now you've got all the background information. So here's the actual text. And so we're going to walk through an example that's probably more understandable than the text, but the hope is that they match. Okay, so I'll read this first. Deprecating instructions as part of an existing conformance group. There's 2 things that you do. You define a new conformance group for the deprecated ones, and you define a new conformance group to supersede the existing ones. Okay, where the new superseding group is going to include the existing one and exclude the deprecated ones. Okay, so let's see an example. And again, this is the case that there's an example in the document itself, and I'm going to basically use that same example in the document. So, okay. So now let's say you're starting from a case like this. Okay. In this example, you got one group, and it's got 4 instructions. Okay. It's called example. There's 4 instructions all in the example group. And we later decide that 1 and 2 was good, but 3 and 4, gosh, those are kind of bad things. We'd like to get rid of 3 and 4. Okay. Such that going forward, there's only A and B, and we'd like to get rid of C and D going forward, or at least, deprecate it going forward, right? And so what do we do to do that? To say, how do we deprecate part of a group without deprecating the entire group, right? Deprecating entire group is easy, right? There you just change the status from permanent to historical, right? That's what kind of Suresh was alluding to before. But here we only want part of that, right? We want to keep some. What do we do? Okay. So the document walks through this. Okay. Here's what in the INA consideration section walks through this. So here's the end state. Okay. So in this case, we create 2 new groups. Okay. One is called legacy example, which are the parts of it that we want to deprecate. On the bottom, you can see we've labeled the ones we want to deprecate with legacy example. But of course, we haven't replaced anything. We now have 2 groups down there because they were still part of example, but now they're also part of legacy example. Okay. And so we said those are now historical. And example B2 says it's everything that's in the example minus the things that are in legacy example. Sorry. So in other words, you first process the includes and then process the excludes, right? That's your order of precedence, right? So you first take example V2, include everything that's in example, and then subtract everything that's in legacy example. That's what you'd run your conformance test or claim support against, okay? So in this case, legacy example is more like a negative group, right? Because it's used in the excludes, right? You don't claim conformance to be legacy example. I suppose you could, but there's probably no practical value. So this one is optimized for, I don't want to deprecate the entire thing. I want to deprecate a small number of instructions. So let's say there was 1 or 2 instructions in base 32 we wanted to deprecate. Again, we don't have to touch all of base 32. We just touch the 1 or 2 that we want to deprecate. Okay. So again, there's 2 different deprecation paths. One is to deprecate an entire group, and one is to deprecate a enumerated type of instructions, and the enumerated set of instructions is what I'm showing in this example. Okay.
So just a quick question, Dave. So I guess the assumption is that if you're deprecating instructions, you'll always have this sort of empty new conformance group that's just a union of an old group with a legacy group. Like you wouldn't, you would never add new instructions or anything like that, I would assume, to such a group.
Could you put these both together and say example v2 adds 2 instructions from the previous one and also deprecates this? You could if you were doing those at the same time. So let's say you had a case where you found that bad example instruction 3 and bad example instruction 4 did it the wrong way, and you want to do the same kind of thing but do it a different way, right? You could do those together and say your example v2, and then you'd have good example instruction 5 and 6 tagged as example v2, and that's basically taking the other example and this example and taking the union of those 2 examples and putting them on the same slide. And that'd be like a replacement. I'm going to replace these 2 with these other 2.
Gotcha. Yep, good point.
Okay. All right, I want to go on because that's the main work that was done last time. And so now I want to talk about current state, meaning working group last call started. And so what's come up since then? I'm now done talking about draft 01, and I'm ready to talk about anything that's past draft 01. All right, so the 2 trivial things that were brought up so far during working group last call only affect the ANA consideration section. Both of these are ANA consideration section only. The main body of the document, no changes. There were some changes to the labels at the last minute that were corrected in the kernel repository before being merged, but the ANA considerations section still had an older set of names, and those just have to be fixed to be the same. So you'll see in there, if you look, Atom 32, that's supposed to be Atomic 32, that's a typo. And the other one, there's a typo in the appendix that was found in those in the implementation reports that I mentioned, which is there's one opcode that's labeled as base 64, where the body says it's supposed to be base 32, and the body is correct, and there's a typo that 32 should be a 64 in the appendix. So yep, those are trivial to fix in the appendix. So
Darren had a question in the chat.
Yeah, okay. I don't know if you want to speak up or if I should just read it. So I can read it out loud. So, all right, so Darren asks, if there are 10 groups between the latest and the one being deprecated, must all groups after the one being deprecated also be deprecated? I'm not completely sure I understand all the question, but I would say, because you asked it with must, I would say, no, you need to do whatever is the simplest administrative way to get the right set of instructions to be deprecated. And so really you want the set of groups to be permanent that somebody would still want to claim conformance to going forward. And it's just, what's the best way to accomplish that? So if you got a suggestion, feel free.
I think another way to say that would be that I don't think every group has to necessarily be derivative of the ones before it. So if you cancel one that's 10 groups before, it would only be relevant if there was like, derivative in the groups between. Yeah.
But we're going to have more than one group. I mean, if you think about the evolution of like CPU versions in in Linux and Clang over time, right? You've gone from CPU equals V1 to V4. Now that we have conformance groups, you could have example 1 through 4 over a 10-year period. That would not be surprising to me. So. Okay. I think I have one more slide in here. Okay, yeah, it's now split into 2 slides, but one issue. Okay, so this one also came up. I posted these 2 slides were in the mail that I sent. I don't know, what was it, like 12 hours ago? I would say today or tomorrow, depending on whether you're local or remote, right? Clarification. So these are cases where I don't think anything is broken, but could something be better worded? I'm starting to think maybe the answer is yes, but I wanted to ask that. So the first way to ask it that I think would be helpful to clarify, I don't know what the answer is, but the point is, whatever the answer is, it would be helpful to have a sentence in there, right? So here's how to phrase the question, okay? This first came up when reading the text about, call helper function by address, okay? So we have, helper function IDs in the old form before using BTF IDs, right? So it says call helper function by address, okay? However, the operand is a 32-bit immediate, right? So you'd say, well, then the address fits in 32 bits. Okay, so this begs the question, well, there's all kinds of, addresses in BPF, and often a VM ISA will say addresses or pointers or whatever are defined as being, 32-bit numbers, or defined as 64-bit numbers, or defined as being up to the CPU. Okay. And so here, the question that would be useful to maybe be more precise about the answer is, well, since a helper function address clearly fits in a 32-bit IMM, at least as worded right now, does this mean all addresses are 32-bit? Should we say that the answer is up to the runtime if it's not 32-bit? And so as an example, okay, somebody reading the document right now would take the example on the bottom of the slide. Okay, at the beginning, let's say you have your input register, say R6, contains a context pointer, right? Now you do an instruction that does a 32-bit move from R6 into R7, okay? And so even if you had a 64-bit pointer on some architectures, sorry, 64-bit register on some architectures, you're taking the bottom 32 bits, okay? And now you try to dereference that should say, there's a typo there, that should say dereferencing R7, not R6, okay? The question is, if I now try to dereference R7, is that valid or not, okay? Well, if it was a 32-bit pointer, then that dereference would be valid. If it needed to use a full 64-bit, it would not be valid. If it's up to the runtime or the CPU, the architecture underneath, then the answer would be it depends. Right now, this is all before JIT time. This is in the BPF VM. Right now, the document doesn't say. And so, is this something that should be clarified? And if so, what's the right document to clarify it in? Do we say that pointers are 64 bits? Do we say that they're 32 bits? Do we say that it depends? Or do we not say? And if we say, then which document do we put that in? This is a question I have for the working group. So,
Christoph, go ahead. Thanks.
So I think the biggest issue here is that I suspect it's mostly just a typo, because the instruction really is obviously not a call by address. If you look how it's used, it's really a call by number, call by RDL, and the right fix is to just clarify that instead of pretending it's an address, which it's not.
Yeah, it's just another form of calling by ID, right?
yeah. So by contrast, if you look at the 64-bit immediate section, right, then you have in the smallest bullet in here, right, we have things like map by IDX over IMM and var address over IMM, which has text that says this will get the address using a 32-bit map index or using a variable ID. But there's nothing in the document right now that's like a helper function, helper address by IDX, which I think is what you're suggesting, Christoph.
I need to look at the documentation, but I mean, in the end, it's not an address. It's just by an assigned number, kind of like the really old school 1990s Linux AOut shared libraries, right? And we just need to make that clear. And I think anything that tries to work like backwards and figure out what is an address from that is just going to get us in trouble, because it's not.
Thanks. Alexei, go ahead.
Yeah, I agree. This is all historical at this point. So this is clearly, as Christoph said, it never was an address. It's an index also, I think, doesn't fit, since it's not really an index, it's more of ID. So call helper function by ID probably fits the best. So like we kind of called it an address because because this is how like LLVM was thinking about it like 10 years ago when it was initially implemented. But like realistically, address 1 and 2, they're nonsensical. Like you cannot have like byte difference between two different addresses. So it's more of a like hack that was back then. It's really, in some ways, it's a relocation. It's like that once the code goes through the verifier, eventually it's got the kernel relocates this ID into proper address, and when it's get jittered, the actual address is used in the call instruction.
And just to clarify for folks, I think what you mean is like we did it that way so that Cling would emit a call instruction to like a non-address, right? It wasn't. It was really just for the compiler to emit a call.
It was combination of many different things. Well, to be precise, it was to not define the whole concept of relocations at this time, when and against what. So it's like
Yeah,
Back
yeah.
then it was just like maps, helpers, and a program. And now we have like BTF, kfuncs, BTF ID, etc. That's why now all we have is this call kfunc by ID, which is this BTF ID is the relocation using like normal like compiler terminology. And here it was, let's hard code some of the IDs starting from 1 to mean like certain addresses. And once they go through the verifier, these IDs get converted to address. So call helper by address is kind of maybe correct depending on the angle you look at, but
it's a JIT. It's an ID that the JIT understands, right?
it's an ID. Yes,
Yeah.
it's an ID, and it is 32-bit. And well, for the last year and a half, we've stopped increasing them. So probably like IDs that we have now in the kernel, that's it. So there will be like no more, because it's a mechanism that has plenty of disadvantages that we like realized. And well, they're there only because you're API and we cannot remove it. But realistically, it's the old way of doing stuff, which is not great. And if you look at how GCC did it, GCC even added a special attribute to call it as kernel helper, to like put this ID instead of address, so it's looks cleaner from like GCC perspective.
Mhm.
So this is all like
Yeah.
historical at this point. And like answering the other question, is this a valid, like your example, if it was like the reference in R7, is it valid pointer dereference? The answer is depends. It depending on what this address is. If it's like a pointer to a context, then on any architecture, even like 32-bit architecture, when a true 64-bit pointer get like reduced to 32, this instruction 1 would not be a valid pointer reference. But if R6 initially had contained a different kind of pointer to a different, let's say, address space, in this address space, the 32-bit may be a valid answer.
Yeah, so I'm going to repeat back what I've heard so far. Thank you. This has been great, great discussion. The first one is the suggestion to change the highlighted word address to something else. After listening to Alexei, then I might suggest legacy ID, because we already have the other instructions. It's call helper function by BTF ID, right? And he said this is kind of old, and so maybe legacy ID wouldn't be an appropriate replacement for that word.
We could, yeah. The other way to look at it is just it's another way for JITs to have two different namespaces of IDs to call functions by. For Linux, it's certainly deprecated. And I think given that we like probably won't fill the 32 bits for BTF IDs, it's probably fine to do either way.
I'm open either way, whatever the working group wants. I'd say from eBPF for Windows, I would expect eBPF Windows to do the same thing as Linux, and that once it has the BTF ID support finished in the various projects that it needs, then it would be using that instead and not be using the legacy ID. So if we called them legacy and said that would be fine with me. So
then legacy is the right way to go if that's the idea.
Yeah. Now, I can't speak for, of course, hardware offload cards and stuff, if there's any different answer that they'd want there, but I'm saying I don't know of any reason to not call it legacy that I've heard so far. So, but on the other question that I asked about, can we clarify how wide pointers are? I heard Alexei explaining it depends. And so I'd said, okay, well, if the answer is it depends, it would be helpful to clarify it in some document. And I don't know whether the ISA is the right document or ABI or the compiler expectations or something else. And so I'd love to have, if somebody actually has an opinion as to what's the right place to clarify that, because the question is begged by reading the ISA document, right? If we say it's left for a different document to answer, that's fine. But if we know an answer and we want to put it in here, that's fine too. You guys tell me.
I think Bitness is really like ESABI document that will talk about like calling convention as well. What's the argument promotion and everything else, including the sizes of pointers. It's like typically it's ABI document that talks about sizes. And just to clarify what I was saying, that it depends whether it's 64 or 32-bit. On x86, the void star is not always 8-byte. So depending which address space you're using, on 64-bit Intel, it may be 4-byte. So pointers can be 32-bit even on Intel. So there is no like surprise. On some special architectures, I think ARC, you can have 16-bit, you can have 12-bit. and some weird like 20+ bit pointers. So it all depends on like address space that these pointers are pointing to.
Yeah, so since this is a new or a different CPU, right? This is the BPF CPU or virtual CPU, right? Then we can define the answer here and what do we want to say, right? So you could say that everything has to be the same. You could say it depends, but my point is we should say whatever the answer is. So what I'm hearing you saying, Alexi, is that saying would best belong in a PSABI document as opposed to in the ISA. Is that correct?
The real question is, does it even matter, right? Because what matters for like the eBPF code generation is how much storage do you need to store the pointer.
Mhm.
And that's pretty clearly defined by the register, and how many bits of those are valid. I mean, this is in like normal processor ABIs that might be important for things like the JVM or other magic interpreted code that wants to steal a few bits from it. And I suspect, at least right now, the answer is you can never steal a bit from a pointer in your eBPF program, period.
Mhm.
And it does not matter how many of the pointer bits actually end up being used by the runtime, because you can't use them anyway.
Even if we said that, Christoph, that would be useful, because that means like if you're going to push a register value that contains a pointer onto into the stack, you're going to consume 8 bytes on a system that uses base 64. Regardless of the width of the pointer, you're going to consume 8 bytes because the register is 8 bytes. That's basically what you said. So, and that would be fine to point out.
Probably something that in one form or another needs to go into this document.
I like the way that you phrased it, because that could be said in one sentence. So.
Yeah.
Okay. Let me finish up to keep us on time, because I have the second part, and this is actually answered half of the next slide. So, go ahead, Alexi.
Just to clarify, so I agree with Christoph that we should document that bits should not be stolen from the 64-bit address space, but this is not really ISA. It's not an instruction set. Right? Like the number of bits is not what like CPUs. It's EBI part. It is like how many like page tables the hardware CPUs have, whether it's like a 4-level page table or 5-level page table. That depends how many bits of the virtual address will be valid, and whether like lower bits can be stolen for like tagging, or whether it's upper bits means this and that. Like all of this is not really in an instruction set document. Like we need to document it, but not in this one, I think.
Yes and no, right? I mean, given that we don't even do page tables in eBPF, of course, it's a little different than a real ISA document that deals with physical and virtual memory and the mapping between the two, which we don't really do because we always operate on, well, it's neither physical nor virtual, on a logical address space. But the important bit for that ISA is basically that if you pass an address to a load and store instruction or any other instruction that takes addresses, just don't mess with it. It's basically a register. An address is a register-sized cookie. Period. Well, it's not a cookie because you do arithmetics on it. Yeah. Okay. Let's take this offline and think about it a little harder.
I would strongly suggest that if we do put this in an ISA doc, this would be like an extension or something. But yeah, we can figure it out.
Okay, so we're taking it to the list then. Now, the next slide is now purely editorial. This one actually had a technical question on it. The next one is purely editorial, and we've actually answered half of it already. So it may be that there's nothing else to do. So, so here's the next one. In the 64-bit immediate instruction section, in the table there, the code adder instruction has a desc type of the words code pointer. Okay, this is the only time in the entire document that the word pointer appears. Okay. The legend of it is useful because it says code adder gets the address. There's the word address, like in the previous slide, which we said the previous slide used it incorrectly. But here's the address of the instruction at a specified relative offset and number of 64-bit instructions. Okay. Now it just points out the editorial point is the term code pointer is not defined other than in the text that I just quoted, which maybe that's a sufficient one. there's actually nothing in the document that says you'd actually ever use a code pointer for something. And that's because there's no instruction that does, but certainly helper functions can. And so that probably is intentional. And so my own opinion is that part is fine, not an issue. Things like jump instructions use offsets, not code pointers. The call instruction, we just said, is irrelevant. And so a reader that sees code pointer and address in a couple places might wonder, why do we use two different terms instead of saying just code address instead of code pointer? Doesn't seem like a big deal to me. And so that's why I didn't really call it out before. But since I was talking about the other issue, it is a little bit related to this one. So I thought I'd call this out too. Should we keep it the way it is, which is fine with me, or should we change the words code pointer to be code address or something like that? You know, I don't care strongly. We've already said that the more detailed discussion goes in another document, whether that's a helper functions document or a PS API or whatever else. But the highlighted text there, is there anything changes we should make to the highlighted text? If there's no consensus, then the answer is leave it the way it is. And so I just want to highlight this because it's relevant to the previous slide too. So that was the other part of the email that I sent, 12 hours ago or so. If I don't hear anything, then it's going to stay the way it is. But if somebody thinks it would be helpful to change one word someplace, then that's easy. So.
Yeah, so I mean, it's pretty obvious that we should not use a straight term that's not defined anywhere. And Alexei may correct me, but I think the simple answer is it's actually an address. And I'm not even sure it should be code address instead of just address. It's an address pointing to the code, yeah.
Correct. Yeah, because the line that I didn't show, there's also a data pointer in an adjacent one. And if we change the word pointer on one, then we'd probably change the other one to be a data address and a code address if we did that.
I mean, it's an address, and we can noodle on the details if we want to define the term code address, say address of the code or something around that, but it should go in that direction.
Yeah, I think address seems like the least ambiguous. Yeah.
Okay. Well, I can generate a patch for that, and people can see whether they like that patch or not. But it's pretty simple. It'd be changing two words in the document from web pointer to address. So, all right. I don't want to spend too much time on it because this one is in the really not that important kind of category compared to some of the other technical ones, like the one that we just walked through. So, all right. This was my last slide on the main ISA. So, any other comments on the main ISA before we move on?
Yeah, thanks, Dave. So there's like two things. Like one of them is like just my point. Like one of the things I figured out is the provisional registration workflow is not defined at all in the document. I'll file an issue on that because it's not clear what happens with the provisional registration. Does it time out? Is it like something that needs to get refreshed? How does it convert to a permanent? It probably needs to get written down somewhere, but I will file an issue after the meeting.
Okay. Yeah. Thank you.
Yeah. And the second thing is like, we would love some more reviews. So like, please, if you are willing to review the document, put your hand up here or like, send a note. We'd love to see more reviews. Yeah. Thanks, Christoph. Sounds good. Darren, the notes indicate that Christoph volunteered to do this. Thank you. Yeah, thanks. Thank you. So Dave, go ahead, please. I think.
Okay, ready for the next presentation then?
Yep, I think you can take it away with Alex.
Okay, so this was a thread that was going on in the mailing list, and I thought I'd just give some visibility here to bring everybody else up to speed as what are we talking about, how can I even follow this thing, and here's here's the current status of things, and so on. So I'm going to try to give a summary of this for the record, at least according to my understanding, and maybe there's other people in there that have more information behind what I put in here, but let's get us on the same page here. So. All right, so some background. We just saw in the other document that there's this call instruction that's only defined for K, meaning the bit is 0, which is defined as call helper function by address, well, by legacy ID, or that ID is in the immediate, right? But there's not defined as what happens if the X bit is 1, okay? Which would be maybe call helper function by legacy ID and a register value. Okay, that's kind of where I'm going with this. The issue is that this call X was never supported by Linux. It was never part of the ISA, so it's never been documented. That said, Clang generates it, and GCC generates it when you use -00 or with Clang or MX BPF with GCC. And so it generates these things. And so is there something we should do about that? Turns out there is interest from other projects in consuming them because compilers actually generate them. Okay? And we could, if we care, we could go into why, but that's not relevant to the question as to why would somebody want to consume it. But the point is they are generated right now, and should we do something about documented those? Is it documented only in Clang and GCC docs? Is it documented in the IETF? Is it provisional? What do we do? So that's what this issue or presentation is about. Okay. This is not saying we should do it in the ISA document itself. Okay. So here's the simplest example, okay, or at least a simple example. So you have some source code, and this is in C, right? You have a function that's a BPF program, and all it does is it calls the helper function with no arguments, and it returns whatever it returns. Okay, so it's a very simple eBPF program. So if you compile it with Clang using 01 or 02, you get the following pair of bytecodes, bytecode operations. Okay, the first instruction says 85, which is that call legacy ID by immediate, and in the immediate you have the value 14. That's the hex 0E, and that's just shown here in a little Indian machine. Okay, so it's calling 14 being that ID that Christoph was mentioning. It's not an address per se; it's a legacy ID that's used to get the address at JIT time or whatever. Okay, so it's a 14 that's encoded in there, and then there's an exit because it returns. Okay, that's great. If you take the same program and you compile it with 00, and the instructions instead look like the bottom. Okay. It's 4 instructions, and it has this thing that Clang shows, and so does GCC, as call X. Okay. Now, this has been around for ages, and it does this. Okay. And you can see if you look at the actual byte instructions, the value 14, there's no 0E in there. So she says, well, where did it put that? Okay. So let me walk you through where it actually puts it. Okay. And how that works. This is your tutorial for everybody that's new here, because even I had to do some research to figure out exactly how this works, and here's what I found. And as far as I know, this is common between GCC and Clang. So, all right. So the BPF code that's compiled is stuck into an L file. And so if we look at that L file, there's a number of sections. Okay. So there's a .data section. And if you're looking for where does it put the 14, well, that's in the data section, right? So the data section here contains, that's the full contents of the data section in the previous program. At offset 0, there's that value of 14. So it's sitting there in the data section. So then how is that used in the program? Okay. Well, there's a section that tells you how to do relocations. So the relocation section for the .text section, where the program is, has a relocation record that says at offset 0 in the text, right, do a 64-bit relocation and replace it with the pointer to the .data section. Right? That's how to read the line at the bottom, right? So what it does is the relocation says that at offset 0 in the text section, which is where the first instruction is, and I'll kind of give a walkthrough on the next slide. It's going to take that and replace it with the actual 64-bit address, the .data section. Okay, so that's what the rel text section says. So going back to that 4-instruction program, okay, that was generated by Clang or GCC, here's what it looks like. Here's the first instruction. And you can see the immediate, the 64-bit immediate there, it's all zeros, okay? The relocation record says to replace the highlighted part with the address of the data section, okay? So then at the end of this one, then R1 will contain the address of the data section. So it's a pointer into the data section at the beginning of it, okay? The next instruction says to dereference the first 64 bits and replace it and stick it in R1. So at the end of instruction 2, R1 now holds the contents of the .data section at offset 0, meaning R1 now holds the value 14. Okay. The next instruction says call X at the value of R1 to get the legacy ID. So this one looks in R1 and says, well, the value is 14, and so I'm going to do exactly the same thing as I would have done if this was call with 14 as the immediate. Okay. Which is why when you turn on optimization, it takes this code here and it optimizes it into a call 14. Okay. As far as Clang and GCC are concerned, these programs are semantically equivalent because one is with optimization, without optimization. It's just where is the legacy ID placed? Is it in the data section or is it in the immediate, directly in the instruction? Okay, this is what Clang and GCC do today and have done for a long time. I don't know when it first came in, but it's been there since long before Clang 11. If I don't know what the first version was. Okay. So the question then The question then is, should we document this in any place other than, Clang docs or GCC docs? And so I saw what Alexi posted in. I'm going to keep going because I actually did this by running these using the version of Clang that was, I think it was Clang 11 that I ran locally, but I think I got 2 different versions of Clang. And so the point is, some versions of Clang do this with O0. And may vary by which version of Clang or whatever else. So I'm not exactly sure, but I can tell you that many versions of Clang does this on different architectures. I've done this multiple times with different compilers. So I think the conclusion of the thread was that it does not, regardless of the answer, it doesn't belong in the ISA document. Okay, so right now this is tagged as a possible extension. Should it be an extension? Should it be left for Clang or GCC docs? Is kind of where discussion could go. There's one wrinkle, which is that older versions of Clang put the register number in the immediate. So if you're going to say R1 is the register, then 1 would go in immediate instead of into the dest reg field. That's fixed in Clang 19. And so Clang 19 and GCC do the same thing of using the dest reg for it. And so one proposal would be to say, well, we could list everything that uses a non-zero IMM field with this opcode as being deprecated, because we know some compilers generate them, but you shouldn't do this. So we could handle that similar to what we did for the legacy packet instructions and just say, don't use those bytecodes for something else because it will conflict with some legacy use, but don't do that going forward. So that would be one way we could possibly do it. And then it would be helpful to clarify things like whether the following is legal or not. And I don't really care about the answer because I don't think there's any code that would do this unless you were trying to construct a test case, right? You could construct a test case by using that code adder instruction we talked about before to say, get a code adder in R1 and now call R1, call X with R1. Once we redefine call to say it's a legacy ID, not an address, I believe that this is automatically answered and that question goes away. So the discussion we had earlier in the meeting answers and makes that question go away. So it still says, what do we do with this call X use that's used by Clang and GCC and has been for some time? What do we do with that? There. Now you are all up to speed on the thread that was going on. So the question is, what, if anything, do we want to do about this in the context of the IETF or in INR registrations? Open discussion, because I'm not sure what the answer is, but this is the time to discuss.
Okay, it looks like I won the race.
Yeah, go for it.
clicking the hand up button. Well, first of all, is I guess the question to you. So it sounds like your main, Dave, like motivation to somehow support compiling with -0, if I understand correctly. So because like it looks like in this whole like slide deck there are like so many things that probably need to be like divide and conquer. So otherwise it's like too many things all at once. So starting with 0. So like BPF code generally, like what you found was this like call X and -0, the optimization that some compilers don't do, like GCC. It is indeed like the problem with -0, but there are like a bunch of other things. So like in taking x86, for example, or ARM, like if you compile the kernel in general, like without any BPF, just kernel, if you compile it with -0, it will compile, but it will not work. Like it won't boot. Like kernel by itself is not like working with -0. So BPF is not working with dash, and the main reason is call stack, size of the stack explosion when you compile anything with 0. Same with BPF. Like if you compile with -0, even let's say we're like hypothetically like making somehow work this call X or whatever or whatnot, whatever is solution, like it's not gonna help BPF programs to be verifiable or usable with -0. This is just like a territory that's like not solvable. I think like kernel is not solving it, and we cannot really like help with like anything doing BPF space. Then in your example here on the slide, you're saying this return get current PID call 14. So this is probably because you're using old definition of this helper. So the link I just posted in IETF chat shows that Clang, all versions of Clang, even with -0, they actually generate call 14 as normal. because the way that this helper should be defined is with the extra const modifier. If there is a const modifier, Clang does the right thing. GCC like has to do this MX BPF thingy. Well, it's up to them like what to do with this. So that's like second part. The third is what is the address? Like since we just agreed to like rename this call helper by address to call helper by legacy ID. In this case, for the call X, so this will not be ID. This on this slide, there's a slide instruction 2 that doing the load. It's not loading any helper ID. This is actually the full 64-bit load. So after instruction 2, R1 has the full address. So that's where it's becoming a different kind of instruction. R1 is actual full address, and indirect call will be indirect call by true absolute address. And it actually matches to what real architectures do. In the normal hardware CPUs, there are only 2 flavors of calls. Either it's a relative call by like PC relative plus offset, or indirect call by absolute address. And the same applies to jump instructions. Jump instructions are the relative jump by PC relative, or indirect jump by absolute address. So when we support call X R1, the instruction number 3 in here, this R1 will mean the full 64-bit address, most likely, but I would not document any of the stuff not yet, because this address also, like as soon as I say it's an address, the question is what address space this address point to. Is this address is actually the full kernel address, or this is actually the address of the BPF program? What this indirect call is jumping to? Is it indirectly calling another BPF program, a function inside BPF program, or directly calling the kernel function? They potentially are in different address spaces. So like it's, I think, like way too early to document any of it, just because like we don't know what will be the real answer once we get to implement this all. And what compilers currently do is more or less like best guess. Like LLVM was doing one thing for the last 10 years, and a couple months ago we changed it from IM to destination register. This is just experimental stuff.
Yeah, so Christoph speaking, I agree a lot with Alex here, right? I mean, if you look at how the eBPF ISA works and you have the immediate versus register bit, it's in general only supposed to mean if you get the same value from the immediate encoding or register, which means if the compiler had actually followed that, you would not actually have an address in here, but you would have the magic number 14 in a register and call that. So
It's a
I
const.
actually think both compilers are doing fundamentally the wrong thing here, which doesn't mean like a real indirect call that has an address, a to be specified address in here could be useful in the future, but it should not be encoded as a call X.
Well, and I think that's Alexi's point with const, right? Like it is actually a constant ID, and it does do the right thing if it realizes it's constant.
Yeah. But it's the compilers are doing something really strange there, and I don't think we should legitimize this. I mean, we might have to put in a warning in there that this opcode has been used incorrectly in incompatible ways by various compilers, but trying to legitimize one of the two behaviors, given that they're both actually wrong, doesn't seem good. Which brings me back to Dave's first slide, or I'm not sure, maybe you just said it and didn't have a slide, but I think you mentioned that you actually had uses for that behavior in some projects.
Prevail and eBPF for Windows.
Potentially, and I can talk about that if it's relevant, but I think that's what Alexei was responding to. And so I was going to take a second and repeat back what I taken away from the feedback so far to see if I've got stuff right in my notes, because if I have it all right, then it could be that the right conclusion is what you just said, Christoph, which is to document the opcodes as used in the same way that we do for the legacy packet ones. We don't say what they do. They just say, danger here, don't use these, right? And list them as deprecated opcodes. That might be the right takeaway.
Packet instructions, which are ugly and shouldn't be used, but they're actually reasonably well defined, which I don't
not in the ISA. the ISA specifically does not define them. It removes all mention of what they do. And so as far as the ISA is concerned, they are undefined. As far as Linux is concerned, they're defined, but that's a Linux thing. It's there at the ISA level. They are have undefined behavior. Don't use them.
Yeah.
I said where I was getting to was to say, if we believe, this is the discussion we had in the last presentation about the word legacy ID. If we believe that the use of legacy IDs are really deprecated because you should just be using BPF IDs anyway, right? That's the same rationale that call X with a legacy ID should also be deprecated. And if it's deprecated, then you don't need to define the behavior, right? And so that's kind of where I'm leading towards in this discussion.
I mean, call by ID is actually very heavily used right now, and at least Linux tries to avoid adding more of it. But to be honest, at least for the one uses we actually want the eBPF standard for in NVMe for some use cases, I suspect we'd actually be better off using them in a tiny, well-constrained environment. But that's a separate discussion.
Just a second. Let me pivot the question to something that I don't think is legacy, because there I think that the discussion can still be wide open and we could have a behavior. Call by BTF ID with the X bit. That is unused and undefined, and so you could define that to do whatever you want, because BTF IDs are the way going forward. Calling by BTF ID, right now we have a way of doing that within the immediate. Do you want to do that with a register? If so, how should that work? Big open question, right? But there's no legacy there to do it. So
orthogonal questions, they're both good questions and probably have different answers. So the thing is, call by ID using immediate is very heavily used right now. Linux as sort of the main eBPF environment has deprecated the use of it in new program types, or maybe even for the extension of existing ones. Alexei will have to get to that. So that's one thing, but it's been very well defined, very heavily used, which can't be said for call by ID in register-ish.
correct.
So I don't think they should be handled the same way. And I think my personal opinion for some of the use cases is actually the call by ID is useful for certain environments that are very resource constrained and limited. But so I would not argue for deprecating it, but I'll hear to people that have even more skin in the game.
Okay, so I'm going to repeat back what I think Alexei's points were to make sure I capture them correctly. He had 3 main points. The first one was that if you use -0, then the experience has been that you can't expect it to work because of things like stack explosion. So you can't really use -0 and expect it to work very well. The second point was about constant IDs, even with 0, that Clang will do the right thing. And so I can see what I was doing differently in my testing or whatever, but there is a way to get Clang with 0 to use the call instruction. And so great information. I will probably use that. And so I will try to figure out how to get that to work. And so thank you for pointing that out. And then the third one that Lexi pointed out was a discussion around maybe when is the 14 replaced with an actual address, right? And I think there was maybe an assumption or an explanation of how it works when it's JITted or whatever. If somebody was doing it in a BPF interpreter, and I'm thinking about like the UBPF project that has an interpreter that uses the BPF conformance suite to test the interpreter there. Not that anybody should use an interpreter, but if somebody does, what's the right behavior there? I think there it actually does have the value of 14, like Christoph said, but the answer might be different depending on whether it's JITted or whatever else. I don't know. And so I think that was Alexei's last point, is it might not be a 14 in some cases. It might be an actual address that's different, and you get different behavior. And so hopefully I've captured the 3 points correctly. If I didn't, please correct my understanding. So.
Yeah, all correct. And just to clarify, I'm not saying that trying to make -0 work is pointless. It can be useful, but it's just like scratching the surface. Like once you scratch the surface, like this colleagues is just like I'm looking at the scratching the surface. Like once you get deeper, any big programs, you will find all sorts of other issues that, and it's not like people didn't try. Like it was on our like to-do list for a while, because with Dasho2, debug information is more or less useless, right? As normal. So that's why in parallel, we're trying to do this kind of Dasho-G that still like optimizes a little bit, but the bug information is good enough that like preserves all the variables and you can see. So this is actually not that specific to BPF, but like other projects on all normal CPUs would like to see this Dash-OG like working, and it's kind of orthogonal effort to all of this. But then back to CallX. So my suggestion is not to list it as deprecated, because like it never existed, it never worked in the kernel, so there is nothing really to deprecate. Also, I wouldn't mark it as reserved yet, though compilers generate it, just because like we can still change it, right? And most likely once we go through the actual implementation of it and supporting the verifier, JITs and everything else, it might change. The encoding might change. It might and might not, right? So I don't see kind of the point of going through the effort of adding into ISA right now with whatever conformance group. It feels to me it just will create a churn, right? So we have very low at this point like confidence that it will stay this way, the way like compilers generate it now. So that's why like I just don't see adding like anything to the doc that worth like doing at this point. But right now, there are people who are working on adding indirect jumps and indirect call to LLVM, to the verifier, to the kernel. So eventually, maybe like 6 months from now, we will like come back with the actual prototype that will do like real indirect calls that will like do the right thing. So at this point, that would be the time to discuss the actual like encoding and what it means.
Okay.
We don't have much time left. I want to make sure that we have time at the end for the last presentation, but I also just want to say that for the Dasho0 thing, yeah, I mean, to me, it's a completely separate issue. Like, I think trying to support Dasho0 is a good idea. It's useful, but if you know, the fact remains that it's a constant address, right? Like it's a const ID, and the fact that the compiler happens to emit a callx because it doesn't happen to realize that it's constant feels very like circumstantial. So I just my personal opinion is, you know, I don't think they necessarily need to be coupled as like goals, for Dasho0.
And I mean, this might be a question for Dave. Do we know of any like JIT runtime environment that actually handles a callx and not just compilers generating it in weird ways?
I don't know offhand of any that already do. I've heard of potential reasons why they might in the future, but I think Alexei was responding to maybe points that they will run into if they tried, and so they might not actually succeed in doing it, right? And so so that's why I wouldn't take it as a yes right now. So that's why I'm fine ending the presentation here. So
if that is
we've
true,
got great discussion.
reach out to the working group. I think the right way to do it is to not mark it deprecated, but to literally put in a footnote, never implemented, but generated in incomparable ways by legacy compilers.
I don't even know if we need to do that. We can just like, but I missed it. I guess the word interest really does mean interest. It doesn't mean that anybody has added formal support for it, which to me,
correct.
I agree with Christoph. Yeah, that it's.
And just to respond to Christoph, it could be that right now the footnote you're talking about doesn't need to be in the IETF document. That could be a footnote in say a Clang notes file in Linux, or in a web page associated with GCC, or a web page associated with llvm.org or whatever. It doesn't have to be in an IETF document. Do that footnote. That's my opinion.
Yeah, I can send a patch for that. That's fine.
All right. Thank you.
Thank you, Dave. Thanks. Is there anything else you want to do? Like, you have the path forward for that, which is to do nothing on the ISA document, right?
Correct. The whole point of it, we'd already decided there was no. That's why it was in a different presentation, right? This is not for the ISA document. This is for some other document, which may or may not even be in the IETF. Unclear, right? Maybe it's a Clang, help document, or maybe it's a GCC help document. Maybe it is in the IETF. I don't know. What I hear Alexei and Christoph saying is that 6 months from now, there may be enough to actually have an IETF document, but probably not before then, right? That's what I'm hearing is the discussion. So.
Yeah. Thanks a lot, Dave. Thank you. I think Nalini or Chinmay, whoever wants to present, like, are you on the on-site tool by any chance, or if you want control, otherwise, Nalini, you can say next. It's either whatever is easier for you. Okay.
By the way, just as a little note for your time concerns, we still got almost an hour. We got 2 hours.
Oh, we have like 25 minutes.
No, we've been here for an hour and a half. It's 11:05.
It sat on a half an hour border. Yeah.
Time flies by.
Yeah, it's a lot of fun. Yeah.
Okay, so I'm Nalini Elkins with Inside Products, and we have two young men with us today, from NITK Surathkal, and they are fourth-year undergraduate students, and they have done the bulk of the work. I am just taking credit. And we've been working together for 2 years, and so here they are.
Yeah, hi everyone. I'm Chinmay. So we have done the implementation of PDM using eBPF. PDM is an IPv6 extension header. So why we chose eBPF for extension header implementation over kernel implementation? So the reason is it takes much less time to develop using eBPF and way less maintenance. Also, the portability is pretty attractive to implement the extension header. Like we can implement in eBPF and we can port it across different kernel versions without much problems. And the BPF verifier also ensures safer implementation for us. Also, the accuracy of timestamp is related to PDM, where we have to capture the timestamp of the packet when it arrives. So wire arrival time would be more accurate in something like PC or XTP.
Chinmay, you can look at that one. It's probably easier.
Oh yeah,
Thanks.
I forgot that. Yeah, so why eBPF over raw sockets? So we don't have to write extra code. We just have to add extension header to a fully crafted packet, and we don't need to modify existing user space applications because the packet is fully crafted by the kernel itself. Next slide. Yeah, coming to implementation of PDM using TCBPF. So PDM is performance and diagnostic metrics. It is described in RFC 8250. It's a destination options header. It is used to measure packet processing and network delays. So the reason we chose TCBPF for this is that we can attach to both ingress and egress of an interface. There is no egress option for XDP as of yet. So we used TCBPF for this. So we used BPF helpers. The BPF helpers we used were BPF SKB adjust room to make space for the packet, and then BPF SKB load data and BPF SKB store data. So store bytes and load bytes. So it is easier to do packet mangling in TCBPF than XDP. So we kind of chose TC for this. Also, the eBPF maps, and since we need to use in both ingress and egress, and we need to be able to access data from the eBPF maps, we have to do object pinning, and we store the 5-tuple state for every single packet. And yeah, so TCBPF provided a nice interface for us to be able to implement the extension header.
Yeah, so we wanted to see how this TCBPF program would perform against kernel implementation. So we tested for 3 things: CPU cycles, network throughput, and packet processing latency. CPU cycles, we wanted to compare with the kernel one. So we used IPF3 to simulate traffic. Our testbed setup was 2 VMs on the same physical host, and both of configurations 8 cores and 16 GB RAM each. And we used perf to get the performance of IPF3, which we're using to simulate the network traffic. And then for network throughput, we just directly got the results of IPF3 without running any perf as such. And for packet processing latency, we used ftrace. So we used it on devq xmit because we couldn't directly get the latency for that particular eBPF program run. And this devq xmit was for the egress program, and then netf receive xkb was for the ingress program, and compared that with the kernel one where we could directly get it for the function itself.
Yeah, sorry, just so when you say compiled into the kernel, do you mean like compiled directly into VM Linux instead of compiling a BPF program?
You mean like for the kernel implementation?
Yeah,
Uh,
like yeah, you compiled it directly into the kernel, and the reason I'm asking this is
Yes.
because BPF runs in kernel space. It's like
yeah.
okay,
Yes. So we compiled it directly into the kernel. Yeah, to
Okay.
clarify.
Thanks.
Yeah, next slide. Yeah, so these are the results for the CPU cycles. The testing that we did was IPF simulating traffic for 5 minutes, and then we ran this 30 times, and this were the results that we got out of it. So we see that eBPF is taking considerably more CPU clock cycles as compared to the kernel one. We also managed to get call stack information and then make a flame graph out of it. So this is not statistically relevant, but we roughly found that the main, the ones that were using CPU cycles the most was mem CPU operations, and then BPF map reads and writes and hashing for those. Right, and we were also using BPF k-time getNS, which wasn't taking up any cycles as such. Yeah, we can go next.
Just comment on the statistical significance. So are you trying to do like more sampling to kind of see if like you're changing the standard deviation or not, like to because like the more you sample, right, you can probably get a better error bound on the thing, right?
Right. So for this test that we have put it up here, we ran for 5 minutes of simulated traffic using IPF 30 times. But for the call stack information, the call stack would take the data that we got was quite huge, so we couldn't run it 30 times. So we ran it quite less, and I don't think we can conclude much about it, but generally speaking, maybe. For network throughput, we see that without PDM, that is without any sort of kernel compilation or eBPF, we see we get a higher bandwidth throughput compared to adding an extension header. That would be expected because we are performing additional operations while adding it. For the kernel implementation, we see a slight decrease, and then for eBPF, it is a bit more of a decrease, but I would say it's overall not that deprecative compared to the benefits that we have using eBPF for running kernel code or modifying kernel state. Yeah, next slide. For packet processing latency, the PDM kernel implementation, that's for the egress function call of in the kernel to add the extension header itself. And that compared with, so we measured devq xmit with the eBPF program attached, and we also measured it without the eBPF program attached to the hook. So we figured out it was devq xmit through the call stack information. And that is for eBPF egress, and hence to get the actual latency of the eBPF program, we just have to subtract the both with and without, and we get around 1.28 microseconds. Compare that with 0.7 of the kernel, we see that it's slightly more, but not extreme. And we also have the same for the eBPF ingress. We couldn't really compare that with the kernel, but that is 0.5 microseconds in itself. In ingress, we just read the packet fields, and in egress, we actually adjust zoom. Yeah, this is some future work that we are planning. One thing is to optimize the eBPF program itself to find out how well we can actually perform compared to the kernel implementation that we did. And like the benefits of eBPF is quite huge, and we would like to see how well it would actually do. Maybe we could handle memory differently. Maybe we could do less BPF SKB writes. That is something to be seen. We also wanted to see, we've tested this in a simple consumer grade 2 VM setup. We also wanted to see how it would do in high performance environments. And then we would also like to see how well this is flexible to implement other extension headers as such in eBPF. Also to try different methods of, finding performance overheads of eBPF programs. Maybe we could also in the future collect cache hits and cache misses and other stuff. So yeah, that's about it for the presentation. If anybody has any thoughts or questions.
Thanks, Amog, and thanks, Chinmay. So, do you have a pointer to the code that you can share on the list? That'll be cool if you have a put it somewhere. Like that'll be good if people can take a look at it. Because if you're asking for is there something better we can do? Maybe it'll be just good to share it and see.
Right. So we have not yet made it open source. We plan on doing so with a suitable license. We'll inform that.
Yeah, this is awesome work. Can you guys share what types of pain points you hit with BPF and where you think like we could improve some sharp edges to make it easier to work with?
Um,
That was perfect. Okay, yeah.
So, I mean, a current pain point in TC at least is it's after everything. So we have to ensure that we don't increase the packet over the MTU, and there is no way that we can actually, add extension headers if we're gonna go over MTU. There's no way to split the packet there at that level. That was one pain point. It's not like it's mostly about like other pain points would mostly be about approachability. The documentation is really good, and it's actually amazing, and we found it easy to follow through. Yes, and
Nice. That's great to hear. Yeah.
yeah,
I don't know why Alexi is laughing, but he's laughing.
I'm laughing along with it. No, that's great to hear because a lot of the time we actually get people tend to ask for more documentation. So it's good to hear. We've been trying, so it's and Red Hat's been submitting a lot of patches, so it's gotten better.
the problem like helper function documentation is great, but to debug some verifier errors, that it gets the instructions and everything, and it's quite hard
That
to understand
part's-
this.
Yeah. Great.
Okay, last call. So thank you very much, and thanks for coming and actually doing it, and then coming and telling us about it. So really appreciate hearing feedback from people who play with this stuff. So thanks a lot. Thank you.
Thank you.
And welcome to your first IETF as well.
Thank you.
Just quick comment. So, is it working? Thank you, for doing all of these experiments. And so Suresh said, share the code. Like without seeing the code, it's hard to give any suggestions. And consider other forums beyond the IETF. Like what you just described, would be, I would say, a great fit for Linux plumbers, like a networking track in Linux plumbers or BPF track. This kind of the talks that people typically give there. And so if you have, once you have code all open source, yeah, I encourage you to present there as well.
Yeah, thank you. Yeah, we'll look in.
Thank you, guys.
Thank you. That concludes our regularly scheduled agenda. So if anybody wants to sing, please come over. But just kidding, don't. So thank you very much, and see you again in next meeting. And please be active on the list. Thank you.
Thanks, everyone. Yeah, thank you.
With the training, totally different topic, but you were mentioning maybe you might make some changes to kind of overall cover. My thinking was, well, you want to have something that is real changes to it. It's going to be pretty hard to real. There's going to be some change, right? And all you need is one more change. It's going to be hard to do five little changes. So one just to get baseline. Primarily what's usually just trying to do the clean out exercise.